Welcome to my Introduction to Networking course, typically abbreviated ITN. This will be for the CCNA version 7 curriculum. Welcome to Module 2, Basic Switch and In-Device Configuration. We're going to be talking about basic Cisco iOS navigation, the command line structure, how to configure a basic Cisco device, how to save the configuration. We're going to talk about some basic port communication and media, talk about how to configure addresses for host devices, and then how we can verify communication between those two devices on a LAN. So we have a lot to cover in this chapter, but most of this is going to be basic layer 2 and basic navigation of the devices. So let's go ahead and jump right in. First section is Cisco iOS. So when we think a computer or a computing device, there is some type of operating system that runs that hardware. And typically the hardware is the physical part. Then the kernel is the communication between the hardware and the software. And then there is the shell, the software portion. We, the user, interact with the shell or software. So we have to have something that will manage between us and the hardware, and that's where that kernel comes into play. More often than not, we think of like a client operating system like Windows 10 or a Mac OS or a Linux OS. But that's not the only thing. Networking devices do have their own operating system. While Windows 10 has a GUI, a graphical user interface, sometimes these GUIs may fail. So we actually have a command line version that works just as well. It's not as graphical, but you don't have to worry about the graphical portion crashing and then you losing the ability to interact with it. So with that, we have certain versions of Linux that are both graphical and command line. So it just kind of depends on what you're looking for and the stability that you are looking for as well. The purpose of an operating system is, again, to allow us to interact with the hardware, but to make it easier. So if we're dealing with a graphical interface, we have a mouse, we have a keyboard, we can move the mouse, we can do things. While we also have a text portion of the operating system, we have a command line that we can also navigate to and from if necessary. Well, in certain operating systems, they don't have a graphical interface, so you can actually choose not to deal with a graphical user interface if necessary. Most Cisco networking devices that we will be dealing with are strictly command line only. So how do we access the command line? We access it through a console cable. This is a traditional console cable up here. It's a DB9 on one side and an RJ45 with a correct pinout on the other. We used to use a program called Telnet to actually connect to a Cisco router. However, Telnet's all plain text and it's not shown to be secure. So that was replaced with Secure Shell, SSH. And this establishes, again, a remote command line, but this allows for encryption, assuming that it has been set up. Both Secure Shell and Telnet can be used when connecting to the networking device's console port. The console port is a management port that is used to, lo and behold, manage the actual device. But that means you have to have physical access to the device. So these types of programs like Telnet and SSH are actually called terminal emulators. They allow us to emulate a terminal to the device. So once we've actually connected to the device, we have to understand our iOS navigation. One of the big things is the different modes. And that's going to be an important thing starting out because how the devices operate is really depending on the mode that they are in. Here we have a device name like router, switch, and a caret. This is called the exec mode, or the user exec mode. And this allows us very limited access to what we can do. Again, you'll notice the caret. Versus our privilege exec mode, which will be a pound. This allows us access to greater options. So here I dragged a routers in packet tracer. I got a router up and running, and I just want to access the terminal. So you'll notice we have just our router and our carets. Do question mark, that's what we can do. We can do ping, we can do disable, we can do some basic show commands, and that's it. If I type enable, we'll go to our privilege exec mode, and you'll notice the amount of commands we can do are tremendously, the list we can do is way longer. So again, depending on the mode that we're operating in, we can do different things. And this will become second nature to you as we use the devices more, because it becomes muscle memory at that point. After that, we have our global configuration. You'll notice it will go to a config. If we are configuring a line specific item like a console or a virtual terminal, we will get a line. If we are looking at a interface, we will be actually at a subcommand, the config-if. These are just some of the interfaces, not all of them. So as we dive deeper into the devices, we will actually be reviewing additional config line syntax and whatnot. So again, there is no video for this, but there is a difference between the user exec mode, privilege exec mode, and our global configuration mode, and how we navigate between them, as well as how we issue commands at each one of them. So how do we navigate between them? If we are at a user mode and we want to go to a privilege exec mode, we will do an enable. That allows us to go to our privilege exec mode. If we want to exit out, we will type exit. How do we go to our global configuration? We could type configure terminal, hit enter. That takes us from our privilege exec mode and puts us in our global configuration mode. That would be this guy right here. If we want to go back to our privilege exec mode, we will do exit, and it will take us back to our privilege exec mode. If we want to configure a line console, for example, in our global configuration, we would type line console 0, and that will allow us to go to our line. Some commands can only be issued at certain locations. So depending at where you are located, are you in the config mode? Are you in the config tac line mode? Are you in the config tac if mode? Certain commands can only be issued in certain areas. So we do need to keep that in mind as we are talking about the navigation of the iOS. So again, learning basic line and console navigation. So if we are looking at a line console, again, we have that sub interface. We can return to the privilege exec mode by doing end or by doing a Control Z. End will take us all the way back. Exit takes us one step out. So if we were in the config tac line and we type exit, it'll take us back to the config. End takes us all the way back to our privilege exec mode. The Control Z is one that you do want to know. I have seen that pop up on a few exams before, just FYI. So to move directly from one sub configuration console to another, you can actually navigate that way. So if we're at the config tac if and we type line console 0, hit enter, it will take us directly to the config-line. So some of those are just going to be times playing with the command line for us to get familiar with, but don't stress too much. We actually do have a lab coming up that will help us go through that. I have prepared other videos that walk us through the navigation, so you should be good with that. So let's talk about the command structure. As we issue commands, we should have a prompt, That will be like the switch and whatever mode we're in. Next will be the command. There should be a space, and there will be either a keyword or an argument. Again, spacing is important, but you need to be careful. If you do 2 spaces, for example, it will think the second space is part of the argument. So the command line is pretty strict on how we do certain things. So basic syntax would be, if it's bold, it's required. If it's italicized, it may not be. Some are going to be optional, some may not. So for example, if we are looking at a help section, ping space, notice ping is in bold, IP address is not, and it's italicized. It's letting us know that ping is the command and that's the argument. If we do switch port security aging, this is an actual printout of the command set. Notice we have static, we have time that is not italicized and not bolded, and then we have type, and then type would be either absolute or inactive. So part of this is learning how we could decode our command line. This is an example of a multi-argument command, where these are singular argument commands. iOS does have a nice help feature. If you do a question mark, it will print out the commands. If you already have part of a command written and you do question mark, it will be the next part of the command. If you fat finger something, or if you try to issue a command at the wrong level, you will actually get an invalid input. I have already prepared videos and linked them as well in the help, or in the chat. So again, some of these videos you can watch later. So hotkeys and shortcuts. You don't always have to type out the entire command. To go from the privilege exec to configuration is configure terminal, or conf t. However, if there could be multiple commands with the same amount of letters, you'll get an ambiguous command. Here we have router, and we're issuing a con command. Well, there are 2 commands that start with con, configure and connect. So this is ambiguous. It doesn't know which one you're trying to do. If you did conf, it would know it's configure. If you did con, it would know that you're typing in connect. So it really just depends. So there's a few other tips. Things like typing out a command, you can hit tab and it will actually complete out the rest of the command, assuming it's not ambiguous. Backspace will erase your character. You can move the cursor up and down characters by left arrow, right arrow, up arrow. Up arrow actually will show you the history, and you can actually go up multiple commands that you previously typed. Other shortcuts are things like Control-Z, which we've already talked about. Control-C, when in a configuration mode, will end the configuration mode and kick you back out to the privilege exec mode. Control-Shift-6 will be an all-purpose break sequence, so that you can break up or kill like a DNS lookup or a traceroute or a ping if any of them get stuck. Spacebar again. If we have a multi-screen help, spacebar will show next screen. Enter hits them one at a time, one line at a time. So again, just some of this is going to be hit and miss while we are practicing our different commands. Again, we've done videos on the shortcut keys. We have a packet tracer file as well. And we have one to do basic navigation. So let's go ahead, let's jump directly into how we can configure the devices now, not just look at navigation. So again, most of the configuration is going to be done at the global configuration mode. So how do we get there? We log into the device, we go from the user exec mode type enable. That gets us to our privileged exec mode. That would be the £. From there, we got to get to our global configuration mode. So conf t or configure terminal, hit enter. That lets us logging into the configuration mode. So we need to, first thing we're going to do is probably name the device. That way it's not just called switch or router. We need to give it a meaningful name. So when we are naming devices, it has to start with a letter, has no spaces, and it must end with a letter or a digit. Only letters, digits, and dashes can be present, and it can be between 1 and 64 characters in length. We can also set passwords. Most of the time in the Cisco curriculum, we are using Cisco or class. However, these are really weak passwords, so we need to not use them in the real world. So some good password guidelines is use passwords that are greater than 8 characters in length, combination of uppercase, lowercase, special characters, and numbers. Avoid using the same password for all devices. Avoid using passwords that are not encrypted on the device if we are assuming we're using passwords for network devices, but I mean for this example that's kind of what we're doing. Don't use commonly guessed words either. So again, we're talking about how to best use the information that we do have. So if we all know that a common password is password, we probably want to steer clear of it. So let's talk how do we configure passwords. Well, we can configure a plain text password by using the command password and then the password we want to set. However, this is not very secure. So here we have we're configuring a basic password for the Align Console 0. We set the password to Cisco. We set it to login. We can, when we go to actually connect, this is going to be the password we connect with. We have the ability to also configure the terminal with a password as well. We would do enable, and then we would either do password or secret, and then the password. If we do the word password here, it's a plain text password. If we do the word secret, it will actually hash our password. If we're talking how to configure a switch, we also have a virtual terminal, so we also want to set our passwords for our virtual terminal. Again, you go to that line, you type in the password, space, whatever password you want, and so forth. So we talked about encrypting passwords. Here we actually have encrypted passwords. Even though we did not encrypt the passwords, we used the command password, and then we did Cisco, for example. Well, why are these hashed values? They're hashed values because we did a password encryption service that actually turned on encryption for all passwords. So that makes these passwords hashed. Even though we didn't hash them to begin with, this service does it for us. So now that we talked about naming and passwords, let's talk about how to set a banner. When you log into the device, here is a message. How do we set that message? We do that by typing banner, MOTD, a special character, type the message, end with the same special character. That allows us to set our messages. And this should be some form of legal message saying authorized personnel only or something of that nature. The pound signs here are delimiter factors or delimiter characters. They don't have to be pound, but whatever you start with, you need to end with. Again, there's a video covering that, which has already been posted. So let's talk how do we save our configuration. If you are doing the configuration, it is stored as a running configuration. The issue is if the device restarts, anything that's running that hasn't been saved will not be there. So we need to actually save the running configuration. We save it to the startup configuration. The startup configuration will be the config that the device will actually load. The running config will be the actual configuration as you've modified it. If you've not saved the running configuration and it is rebooted, whatever startup configuration is there is what will load. So how do we save it? In a global config, we can do not in global config. If we make any modification in our global configuration, we should be saving our config. We do the saving by going to our privilege exec mode and typing copy running -config space startup config. Or you can do the shorter version, which is copy run start, hit enter, and it will save the configuration. If there are changes made to the running configuration and it's not saved, when there is a reboot, the changes aren't there. If you issue a reload, the reload will actually restart the device, and the reload will actually load the startup configuration. If you want to delete the startup configuration, again from our privilege exec mode, you would type erase startup config, and that will blank out the startup config. Once you've erased the startup config, you need to reload or restart the router or the device so that it will load a blank configuration. Because again, when the device is turned on, it's whatever configuration it has in memory is known as the running config. So even if you erase the startup config, the device is still running the running configuration until you reload it. Again, there is a video which we're not going to be covering. So again, how do we actually save our output? We can actually, if we're using puttying, you can log all of the information in the terminal session. You can actually go through and copy and paste it into a text document. You can do session logging, you can disable logging, kind of just depends on what you want. We have Packet Tracer outlining how to do the basic configuration and how to do the saving, and how to configure a switch. Moving on, we're going to talk about how to configure our end devices with ports and IP addresses. So again, IP addresses are outside the scope of this video, so let's just assume we're given our IP addresses and we can issue them manually. If we're talking with Windows 10, we'd go to our network configuration and we would use the following addresses, and you'd manually type in the addresses. If we're talking IPv6, we again would be given the IPv6 address and the default gateway and our prefix, and we would use those pieces of information. Again, IPv4 and IPv6 are discussed in a later module. So here we're just talking our logical addressing for communication. Moving on, let's talk about ports and interfaces. So how do we plug things in? So we have copper-based switches, and these will use Ethernet cables. The Ethernet has an RJ45 on the end. These are copper. They're twisted copper all the way through. If we have a fiber optic connection, we actually have fiber cable, and fiber has multiple different types of media types and plugins. Kind of just depends on what type of device we have and what plug that we actually have connected to that device. Next we have wireless. We have a lot of wireless devices. So one thing they all have in common is if we're dealing with copper, we have to have some type of network interface card with the appropriate interface, a NIC, N-I-C. If we have fiber optic, we have to have a fiber optic NIC with, again, the appropriate interface. If we have wireless, we'll have a wireless NIC. That allows us to connect to that medium using the choice of media. So to connect to a wireless network, we have to have a wireless card. To connect to a fiber network, we have to have a fiber card. If we have to connect to a copper-based network, we have to have an Ethernet card. which I mean, most network cards are going to be RJ45, which will be this copper connection, just because that's the basic standard. So again, the three types: copper, fiber, wireless. Copper is going to be the most prevalent, and that's going to be some type of Ethernet cable with a RJ45. If you're looking at like a phone cable, an RJ45 looks very similar to that, but a phone cable is an RJ11. It's slightly smaller than a RJ45 connection. So once we actually have a physical connection, let's say with copper, how do things communicate? They actually have to have a logical address assigned, hence the next section being configuring the IP addresses. So again, back to this screen. So how do we get to this screen? Well, first we're assuming we have to manually configure the addresses. We are assuming no dynamic address assignment is available, meaning there is no DHCP server running on the network. So, how do we get to this screen? If you're in Windows, we'd go to Control Panel, Networking Sharing Center, would be looking at some type of an adapter setting, and we would be looking at the properties of our network adapter. From there, we'd be going to the IPv4 settings, and that is where we can manually set our IP address, subnet, default gateway, and DNS. If we actually do have DHCP, we would leave them as obtain automatically, and that would be all we need to do. If we're talking IPv6, IPv6 actually has a dynamic address association without DHCP. That's outside the scope of this video. For some reason, we're going to talk about giving a switch an IP address this early in the course, so we can actually configure a IP address to a layer 2 switch for management capability. So if we go to our switch, go to our global configuration mode, and we go to interface VLAN 1, that's a virtual interface, and we can assign an IP address to that switch by typing IP address, type in the address of the switch that we want to give it, and the appropriate subnet mask. That should be the same IP address network that that switch is attached to. We actually have a lab doing basic configuration, configuring the switches, configuring the PCs, and setting up a switch virtual interface. Lastly, once everything is set up, we need to verify connectivity. So how we do that is by doing certain commands like ping and traceroute, which again is outside the scope of this video, which we'll be covering on our next video. So now that we've covered basic device configuration, and we've talked about how to configure addresses and how physical media connections and things of that nature, we should have the ability to do some basic configuration. So we're going to have a lab where we configure basic commands or basic features of a switch and router using basic Cisco IOS commands. We're going to set up topologies, set up our PCs, configure a very basic level switch configuration to reinforce kind of what we've learned. What did we learn in this module? We learned about the overall structure of the Cisco IOS. We learned about how to navigate the IOS, and we learned about the device mediums that will allow us to connect our in devices to other networking devices, again copper, fiber optic, or wireless. And we talked about basic IP addressing and how to allocate them both statically and dynamically to in devices. And that is it for this lecture or this module. If you have any questions, please reach out. Thank you.